All right, we're going to talk about linear functions today. So what's a linear function? Well, there's a couple different parts of this. The first part is this function part. And so a function, remember, is something that relates two things together, and it does so in a special way so that no domain element is repeated or no domain element is doing double duty and being paired with two separate range elements. Linear, this is kind of our new word here. Linear basically means if you graph this, then you get a line, a straight line. So not a curved line, but a straight line. There are several different forms of linear functions. We're going to start with sort of the most basic, which is f of x equals mx plus b, or y equals mx plus b. Okay? This is commonly known as the slope-intercept form of a linear equation. Okay, now there are two other forms of linear equations that we're going to talk about, point-slope form and also standard form. We'll talk about those in the next section. But slope-intercept form is kind of where we're going to spend most of our time in this class. It's the form we're going to use the most. It's the one we're going to really kind of dig into. So let's talk about what slope-intercept means. When I'm dealing with a linear function, y equals mx plus b, or f of x equals mx plus b, these are the same thing. What this is doing is this is giving me a way to find x, y pairs. Okay? And when I'm thinking about a linear function, there are some special parts of this linear function. This m is the slope of the linear function, and this b is the y-intercept. So you can see why we call this slope-intercept form, because it involves the slope and specifically the y-intercept of an equation. And so based on the idea of a slope and a y-intercept, we can sketch a graph of a line if we know those two things. We're going to talk about how we do that in a minute. But what I want to focus on here for just a second is the idea of linear versus non-linear and how we recognize if something is linear or not linear. Okay? Well, if we're looking at a graph, it's pretty straightforward to decide whether or not something is linear, right? Linear things are lines. So if I have a little Cartesian coordinate system here, if I take a function or an equation and I graph it and I get something that is a line, well, then that was a linear equation. Now we're going to see that lines come in different flavors. They can be increasing or have positive slope. They can be decreasing or have negative slope. They can be flat, so a horizontal line that has slope 0. And then we could also draw a line vertically, although we'll talk a little bit later about why that's not actually a function. It's because it fails the vertical line test, okay? But all of these represent lines, okay, or linear equations, not counting the orange one. These are all also examples of linear functions. Okay? Now that is in opposition to, if we're thinking graphically, right? Well, there's lots of things I can draw on a graph that are not linear. So for example, this is a parabola, which comes from a quadratic equation, shaped like this, right? That's not linear, it's not a straight line. Things like this, okay? Or even weirder things like periodic functions, right? All of these, while still functions, are non-linear functions. So linear functions give us a line, non-linear functions give us curves, okay? And if we think about what that means for whatever we're graphing, right? Oftentimes graphs are representing real things, things in the real world. If something is linear, it means it has a constant rate of change. So what does that mean? Well, it means this is increasing at a constant rate. We're not kind of swerving all over the place. We're steady. We're increasing constantly or decreasing constantly. Or in the case of this blue line, neither increasing nor decreasing, okay? We're going to talk more about that as we talk about the slope, because it turns out the slope tells us about the rate of change of this line, okay? But big idea, linear function gives us the graph of a line as opposed to another curve, so a straight line. We're going to deal with slope-intercept right now, and so that's the form y equals mx plus b, where m is our slope. We're going to talk more about slope in the next video, and b is our y-intercept. We talked about y-intercepts and x-intercepts in the last section.